Differentiate with respect to x, cot inverse inside the bracket under root of 1 plus sine 4x upon 3 plus under root of 1 minus sine 4x upon 3 divided by under root of 1 plus sine 4x upon 3 minus under root of 1 minus 4x upon 3. In this way, we have been asked to differentiate this given function of cot inverse. So first step is we will assume this given function as y. Now we will observe the term inside the bracket. So after observation, what we can see that in numerator we have 1 plus sine 4x upon 3, and in denominator also we have 1 plus sine 4x upon 3. So what I will do, hi everyone, welcome to daily practice. In this video I will explain you solution of 5 different questions. So I urge you to watch this video till end so that you will get complete understanding of each and every step of the solutions. If you face any doubt, you can share it in the comment box or DM it to my Instagram handle. And if you are new to this channel, do subscribe it and share it with your friends. So without any further delay, let's start solving these questions. Differentiate with respect to x. So we have to differentiate with respect to x the given function, that is cosec inverse of 1 upon 4 cos cube 2x minus 3 cos 2x. Usually while solving these questions, we first assume the given function as y. Y is equal to cosec inverse of 1 upon 4 cos cube 2x minus 3 cos 2x. Now I will convert this cosec inverse into sine inverse. How? Sine inverse of, now while I convert this cosec into sine, this 1 upon 4 cos cube 2x minus 3 cos 2x will become 4 cos cube 2x minus 3 cos 2x. I have used this relation. Cosec inverse of 1 upon a is equal to sine inverse of a. Now what I will do, as you can see here, we have 4 cos cube 2x minus 3 cos 2x. What I will do, I will use the formula for cos 3 theta is equal to 4 cos cube theta minus 3 cos theta. After using this formula, what I will get, this step will become sine inverse of cos, here theta is equal to 2x, so 3 theta will be 3 into 2x. Therefore y is equal to sine inverse of cos 3 to the 6x. Now I will convert this cos into sine. So what I will get, sine inverse of sine pi by 2 minus 6x. So in this way I have converted the term inside the bracket in terms of sine. Now this sine inverse and sine will get cancelled. Then I will be left with y is equal to pi by 2 minus 6x. Now as I have simplified the given function in terms of y is equal to pi by 2 minus 6x, Then I will differentiate this function with respect to x. Then what I will get? Dy by dx is equal to, this pi by 2 is constant, so its derivative 0, and derivative of x with respect to x will be 1. Therefore dy by dx will be equal to minus 6. This is the required answer. I hope you have understood each and every step that is involved in this solution. If that is the case, then give this video a thumbs up. And if you have any doubt, you can share it in the comment box. Now let's move to the next question. Differentiate with respect to x tan inverse of, inside the bracket, 1 plus cos x upon 3 divided by sin x upon 3. So we have to differentiate this term. So first step is we assume the given function as y. Then we observe the function which is given to us, that is tan inverse. So in order to cancel out this tan inverse, we will have to convert the term inside the bracket in terms of tan, so that this tan inverse and this tan will get cancelled, and then we will be left with this simplified function, which we will be differentiating with respect to x. Now how to convert it? Let me show you. First I will write this 1 plus cos x upon 3 divided by sin x upon 3. Then I have the formula 1 plus cos 2 theta is equal to 2 cos square theta, and sin 2 theta is equal to 2 sin theta into cos theta. So I will apply these two formula for this fraction. So 1 plus cos x upon 3 divided by sin x upon 3. Now I will adjust this theta in this way. 1 plus cos 2 inside the bracket x upon 6 divided by sin 2 inside the bracket x upon 6. I hope you have understood the adjustment I have made. Why I have made this adjustment? So that I can use these formulas. As you can see that here I have 2 theta and here I have 2 theta. So I have adjusted the given angles x upon 3 in terms of this 2 theta. Now once I have made this adjustment, I can use this formula. Here 1 plus cos theta is equal to 1 plus cos 2 theta is equal to 2 cos square theta. So what I will get? This will be equal to 2 cos square. Here theta is x upon 6. So x upon 6 divided by sin 2 theta. This sin 2 theta I will apply to this denominator. Then what I will get? 2 sin, here theta is x upon 6. So I will put theta is equal to x upon 6 in this formula. Then what I will get? 2 sin x by 6 into cos x by 6. Now as I have used this formula, I have got 2 cos square x by 6 divided by 2 sin x by 6 into cos x by 6. Now here you can see that we have two as a common term in numerator and denominator. So these two will get cancelled. Then here we have cos x by 6 in denominator and cos square x by 6. So 1 cos x by 6 in numerator and this cos x by 6 in denominator will get cancelled. So we will be left with cos x by 6 in numerator and sin x by 6 in denominator. So cos x by 6 upon sin x by 6 will give me cot x by 6. Now we have to convert the term inside the bracket in terms of tan. So this cot I will convert in terms of tan. So how to do that? Tan of pi by 2 minus x by 6. So in this way I have converted the term inside the bracket in terms of tan. So I will put this tan pi by 2 minus 6 in this given function. Then what I will get? Y is equal to tan inverse of tan pi by 2 minus x by 6. This tan inverse and tan will get cancelled. Then I will be left with pi by 2 minus x by 6. So in this way I have simplified the given function in terms of pi by 2 minus x by 6. Now I can differentiate this with respect to x. So what I will get? Differentiate with respect to x. Then I will get dy by dx is equal to derivative of pi by 2 with respect to x is 0 as it is a constant minus this 1 upon 6 as it is. Derivative of x with respect to x is 1. Therefore dy by dx is equal to minus 1 upon 6, which is our final answer. So in this way we solve this given question. I hope you have understood each and every step of this solution. If that is the case, then give this video a thumbs up, share it with your friends. And if you face any doubt, you can share it in the comment box or you can DM it to my Instagram handle. Now let us solve next question. Differentiate with respect to x cot inverse of sin 3x upon 1 plus cos 3x. So here you can see that we have to differentiate this function of cot. So I will assume this given function as y. Now I will convert this cot function into tan function. So tan inverse of 1 plus cos 3x divided by sin 3x. Here I have used cot 1 upon a is equal to cot inverse of 1 upon a is equal to tan inverse of a. Now here you can see that I have the function of tan inverse. So what I will have to do? I will have to convert the term inside the bracket in terms of tan, so that this tan inverse and this term inside the bracket, that is tan, will get cancelled and we will be left with this simplified function. So we will convert this term inside the bracket in terms of tan. Now how to do that? Let me show you. First I will note down this term inside the bracket, 1 plus cos 3x upon sin 3x is equal to. Now what I will do? We have the formula 1 plus cos 2 theta is equal to 2 cos square theta, and we also have the formula sin 2 theta is equal to 2 sin theta into cos theta. So these are the formula that we are going to use to simplify this numerator and denominator. Now how to do that, let me show you. Now what I will do, I will make adjustments so that I can have 2 which will be multiplied with the value of angle which is inside the bracket. So what I will do, I will make an adjustment 1 plus cos 2 3x upon 2 divided by sin 2 inside the bracket 3x upon 2. Here you can see that when I cancel this 2 in numerator and denominator, then I will be left with cos 3x, which you can see here. Similarly, in denominator, I have made this adjustment such that this 2 and 2 will get cancelled and I will be left with this 3x. So in this way I have made the adjustment. Now you can see over here, I will compare this numerator with this formula. Then what I will get, the value of theta will be 3x upon 2. Similarly, I will compare denominator with sin 2 theta. Then what I will get, the value of theta will be 3x upon 2. Therefore, what I will do, I will put this value of theta in this RHS, which is simplified form of this given functions. So what I will get after substituting this theta in this RHS, see, first term is 1 plus cos 2 theta is equal to 2 cos square theta, and here theta is 3x upon 2. So what I will get, 2 cos square 3x upon 2. So I will write it over here, 2 cos square 3x upon 2 divided by, now in denominator I have sin 2 3x upon 2, which is similar to sin 2 theta. Therefore I got the value of theta as 3x upon 2. So I will put this value of theta 3x upon 2 in this RHS of this formula. Then what I will get, 2 into sin theta, here theta is 3x upon 2, so 3x upon 2 multiplied by cos theta, that is 3x upon 2. So in this way I have expanded the numerator and denominator. Now you can see that I have 2 common in numerator and denominator, so I will cancel it out. And here you can see that I have cos square 3x upon 2 in numerator, and in denominator I have cos 3x upon 2. So 1 cos 3x upon 2 will cancel from numerator and 1 from denominator. Then I will be left with cos 3x upon 2 divided by sin 3x upon 2, which is equal to cot of 3x upon 2. Now here you can see that I have tan inverse, so I will convert this cot into tan. Then what I will get, tan of pi by 2 minus 2. So in this way I have converted the term inside the bracket in terms of tan, that is tan pi by 2 minus 3x upon 2. Y is equal to tan inverse of pi by 2 minus 3x upon 2. Now here you can see that this tan inverse and tan will get cancelled. Then I will be left with y is equal to pi by 2 minus 3 upon 2 x. As we have simplified the given function, now we can differentiate it with respect to x. So what I will get, dy by dx is equal to derivative of pi by 2 with respect to x is 0 as it is a constant function. So 0 minus 3 upon 2 into derivative of x with respect to x will be 1. Therefore, dy by dx is equal to minus 3 upon 2 into 1 will be minus 3 upon 2, which is our final answer for this question. I hope you have understood. Now let's move to the next question. Tan inverse inside the bracket cos 7x divided by 1 plus sin 7x. We have to differentiate this function. So first step is we assume the given function as y. So y is equal to tan inverse of cos 7x divided by 1 plus sin 7x. Now here you can see that we have tan inverse. So we have to convert this given function inside the bracket in terms of tan. Now how to do that? First I will consider cos 7x divided by 1 plus sin 7x. Then I will use the formula cos 2 theta is equal to cos square theta minus sin square theta, and to simplify this 1 plus sin x, I will use the formula sin 2 theta is equal to 2 sin theta into cos theta, and to expand this 1 I will use the identity sin square theta plus cos square theta is equal to 1. Now first of all what I will do, I will write this given function in terms of this cos 2 theta sin 2 theta. Then what I will get, I will make a small adjustment to write it in terms of cos 2 theta. I will adjust 2 in this way, 2 into 7x upon 2 divided by 1 plus sin 2 into 7x upon 2. So in this way I have converted this numerator and denominator in terms of cos 2 theta and sin 2 theta by making this small adjustment. Now here you can see that in numerator and denominator I have adjusted numerator cos 7x in terms of cos 2 theta as 2 into sin 7x upon 2. So on equating this both numerator and denominator, the value of theta that I obtained is theta is equal to 7x upon 2. Now I will put this 7x upon 2, theta is equal to 7x upon 2 in the RHS of these formulas. So what I will get, cos 2 7x upon 2 will become cos square theta, theta is 7x upon 2 minus sin square theta, that is sin square 7x upon 2 divided by, I will put this theta in this trigonometric identity. Then what I will get, sin square 7x upon 2 plus cos square 7x upon 2 plus 2. Now I will put the value of sin 2 7x upon 2, which will be equal to 2 sin theta, theta is 7x upon 2, so 2 sin 7x upon 2 into cos 7x upon 2, 2 sin 7x upon 2 into cos 7x upon 2. So in this way I have expanded the given terms in numerator and denominator. Here you can see that numerator has been converted in the form a square minus b square, and in denominator it is converted in the form of a plus b plus a square plus b square plus 2ab. Therefore I will write it therefore I will use formulas. Then what I will get? This cos square 7x upon 2 minus sin square 7x upon 2 will be written as cos 7x upon 2 minus sin 7x upon 2 into cos 7x upon 2 plus sin 7x upon 2 divided by, in denominator we have sin square 7x upon 2 plus cos square 7x upon 2 plus 2 sin 7x upon 2 into cos 7x upon 2 written in the form of a square plus b square plus 2ab. So this is the expanded form of a plus b bracket square. So cos 7x upon 2 plus sin 7x upon 2 bracket raised to 2. So in this way I have converted the denominator using the formula for a square plus b square plus 2ab, which is equal to a plus b bracket square. Now here you can see that cos 7x upon 2 plus sin 7x upon 2 in numerator and 1 cos 7x upon 2 plus sin 7x upon 2 bracket square will get cancelled, and from denominator one term will get cancelled. So I will be left with cos 7x upon 2 minus sin 7x upon 2 divided by cos 7x upon 2 plus sin 7x upon 2. Now I have to convert this numerator and denominator in the form of tan. So how to do that? I will divide this numerator and denominator by cos 7x upon 2. I will divide this numerator by cos 7x upon 2 and denominator by cos 7x upon 2. Then this cos and this cos will get cancelled and I will be left with 1 minus this sin 7x upon 2 divided by cos 7x upon 2 will get converted into minus tan 7x upon 2 divided by. Similarly, in denominator this cos 7x upon 2 and this cos 7x upon 2 will get cancelled and I will be left with 1. This sin 7x upon 2 and cos 7x upon 2 will get converted into tan 7x upon 2. Now here I have tan inverse. So I will convert this term inside the bracket in terms of a minus b divided by 1 plus a into b. Then its expansion will be tan inverse of a minus tan inverse of b. In order to convert the term inside the bracket in this form, what I will have to do, I have to make some adjustment. Now here you can see that here I have 1. In denominator I have 1. Now the second term in the denominator, tan 7x upon 2, is multiplied with 1. So what I will do, I will replace this 1 with tan pi by 4. Now why tan pi by 4? This tan pi by 4 will be equal to this a. If I put tan pi by 4 as a, then this tan and this tan inverse will get cancelled. Then I will be left with pi by 4. Similarly, this tan 7x upon 2 will be substituted as the value of b. Then this tan and this tan inverse will get cancelled out. Then I will be left with 7x upon 2. Then pi by 4 minus 7x upon 2 will be differentiated with respect to x. And in this way, we will simplify this given function. So I will put this tan pi by 4 in numerator and in denominator as well. Then what I will get, tan pi by 4 minus tan 7x upon 2 divided by 1 plus tan pi by 4 into tan 7x upon 2. Now I will put this simplified form in the given function. Then what I will get, y is equal to tan inverse of tan pi by 4 minus tan 7x upon 2 divided by 1 plus tan pi by 4 into tan 7x upon 2. Now here I will use the formula tan inverse of a minus b upon 1 plus a into b, which is equal to tan inverse of a minus tan inverse of b. Then what I will get, here value of a is tan pi by 4 and value of b is tan 7x upon 2. Then I will apply this formula. Then what I will get, tan inverse of a, here a is tan pi by 4 minus, we will take that minus sign as it is as per the formula. Then minus tan inverse of b, here b is tan 7x upon 2. Now here you can see that this tan inverse and tan will get cancelled. So I will be left with pi by 4 minus, here tan inverse and tan will get cancelled. I will be left with 7x upon 2. So in this way, we simplify this given function of tan inverse cos 7x upon 1 plus sin 7x. Now as we have simplified the given function, we will differentiate it with respect to x. Then what I will get, dy by dx is equal to derivative of pi by 4, which is a constant function, with respect to x will be 0, minus this minus sign as it is. 7 upon 2 as it is. Derivative of x with respect to x is 1. Therefore, dy by dx is equal to minus 7 upon 2, which is our final answer. In this way, I have solved the given question. If you have understood each and every step of the solution, give this video a thumbs up, share it with your friends, share your doubts in the comment box. Now we will solve next question. Differentiate with respect to x tan inverse of cosec x plus cot x. So we have to differentiate this tan inverse of cosec x plus cot x. Now first step is assume given function as y is equal to tan inverse of cosec x plus cot x. Then I will write this cosec x as 1 upon sin x and this cot x as cos x upon sin x. Then sin x is the common denominator, so numerator will be 1 plus. Now here you can see that I have 1 plus cos x and in denominator I have sin x. So what I will do, I will mark this as equation 1 and I will note down this 1 plus cos x upon sin x. Then I will use the formula 1 plus cos 2 theta is equal to 2 cos square theta, and to expand this sin x I will use the formula sin 2 theta is equal to 2 sin theta into cos theta. Now here the value of 2 theta is equal to x, therefore theta will be equal to x by 2. Now wherever there is theta in RHS, we will write x by 2 instead of theta while expanding this numerator and denominator. Therefore 1 plus cos x will be written as 2 cos square theta, that is x by 2. 2 cos square theta, that is theta is x by 2. So 2 cos square x by 2. And denominator will be written as sin x, that is sin 2 theta is equal to 2 sin theta into cos theta. Now instead of 2 theta put x and instead of theta put x by 2. Then whatever the value of RHS we get after substituting these values, that will be expanded form of this sin x, which is equal to 2 sin x by 2 into cos x by 2. Now here you can see that we have 2 in numerator and denominator, they both will get cancelled. Then we have cos square x by 2 in numerator and in denominator we have cos x by 2. So 1 cos x by 2 in denominator and 1 cos x by 2 in numerator will get cancelled out, and we will be left with cos x by 2 divided by sin x by 2, which will be equal to cot of x by 2. Now here we have tan inverse, so we have to convert this cot in terms of tan. So what I will get, tan of pi by 2 minus x by 2. Now we will put this value in equation number 1. Then what I will get, y is equal to tan inverse of tan y by 2 minus x by 2. So after substitution, this tan inverse and tan will get cancelled. Then we will be left with y is equal to pi by 2 minus x by 2. On differentiating both the sides, what I will get? Differentiate with respect to x. Then what I will get? Dy by dx is equal to derivative of pi by 2 with respect to x is 0 as it is a constant function. Then this minus 1 upon 2 as it is. Then derivative of x with respect to x is 1. Therefore, the value of dy by dx is equal to minus 1 upon 2. This is our final answer. I hope you have understood each and every step of this solution. If that is the case, then give this video a thumbs up, share it with your friends, and if you have a doubt, share it in the comment box. Now we will solve next question. Differentiate with respect to x cot inverse inside the bracket under root of 1 plus sine 4x upon 3 plus under root of 1 minus sine 4x upon 3 divided by under root of 1 plus sine 4x upon 3 minus under root of 1 minus 4x upon 3. In this way, we have been asked to differentiate this given function of cot inverse. So first step is we will assume this given function as y. Now we will observe the term inside the bracket. So after observation, what we can say that in numerator we have 1 plus sine 4x upon 3, and in denominator also we have 1 plus sine 4x upon 3. So what I will do, we will assume this 1 plus sine 4x upon 3 as a, and this 1 minus sine 4x upon 3 in numerator and denominator we will assume it as 1 minus sine 4x upon 3. We will assume it as b. Then we will put this value of a and b in this term inside the bracket. Then what we will get? Under root of a plus under root of b divided by under root of a minus under root of b. Now what I will do? Rationalize the denominator. So a plus under root of b divided by under root of a minus under root of b. Now we have to rationalize the denominator. So we will multiply the denominator with its conjugate pair. So its conjugate pair is under root of a plus under root of b. In order to cancel this under root of a plus under root of b, I will multiply numerator with under root of a plus under root of b. Therefore, on expansion, what I will get? A plus b plus 2 under root of a into b divided by, here what I will get? A minus b. Now here what I will do? This a plus b will become a plus b. A plus b will become 2. This a into b will become a into b will become 1 minus sine square 4x upon 3, which will be equal to cos square 4x upon 3. Then we have under root of a into b. So under root of a into b will be under root of cos square 4x upon 3, which is equal to cos 4x upon 3. And a minus b will be equal to a minus b will give us 2 sine 4x upon 3. So now I have the value of a minus b, a plus b, and under root of a into b. So I will put all these values over here, and what I will get, a plus b will be equal to 2 plus this 2 as it is. A into b will be cos 4x upon 3 divided by this a minus b will be replaced with 2 sine 4x upon 3. 2 sine 4x upon 3. Now I will take 2 as a common from numerator. Then what I will get? 2 into 1 plus cos 4x upon 3 divided by 2 sine 4x upon 3. 2 sine 4x upon 3. 2 will get cancelled. Then I will be left with 1 plus cos 4x upon 3 divided by sine of 4x upon 3. Now we know how to adjust over here. So 1 plus cos 4x upon 3 will become 2 cos square 2x upon 3 divided by 2 sine 2x upon 3 into cos 2x upon 3. Now 1 cos 2x upon 3 in denominator will get cancelled with 1 cos 2x upon 3 in numerators, and this 2 and 2 also will get cancelled from numerator and denominator. Then I will be left with cos 2x upon 3 divided by sine 2x upon 3. So cos upon sine will give me cot of 2x upon 3. So in this way we have converted the term inside the bracket in terms of cot 2x upon 3. So this entire term is equal to cot of 2x upon 3. So I will put this cot 2x upon 3 in this bracket. Then what I will get? Y is equal to cot inverse of cot 2x upon 3. Therefore y is equal to, this cot inverse and cot will get cancelled. Then I will be left with y is equal to 2x upon 3. So in this way I have simplified this given function in terms of y is equal to 2x upon 3. Now as it is simplified, we will differentiate it with respect to x. Then what I will get? Dy by dx is equal to 2 upon 3 into derivative of x with respect to x is 1. Therefore dy by dx is equal to 2 upon 3. This is our final answer for this question. So in this way we solve this given question. If you have understood each and every step of this solution, give this video a thumbs up, share it with your friends, and don't forget to subscribe this channel.